Hey, it's Mr. Lineski here with Unit 7, Section 1. We're going to look at simplifying radicals, ratios, and proportions. So let's take a look at what this is all about. A little bit of review for algebra, talking about simplifying radicals. Back in algebra, you should have learned a list of what were called perfect square numbers. Perfect square numbers are 1, 4, 9, 16, 25, etc. These numbers, perfect squares, come from taking our counting numbers and squaring them. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and that goes all the way up to 15. So this is a list of numbers that you should know or kind of have memorized as perfect square numbers. So back in algebra, you had problems where you were simplifying and putting things in simplest radical form. So if I had a problem like what's the square root of 36, that's something I can punch into my calculator and it tells me that it is just 6. So that one's pretty easy. 36 is a perfect square number. However, if I type in the square root of 12, we kind of get a weird messy decimal of like 3 point something or another. So we don't want it as a decimal, and that's sort of in our directions here, no decimals. So we leave it in simplest radical form, meaning that we're going to kind of break it apart into pieces. When we break it apart into pieces, there are different strategies to go about doing this. The strategy that I like the best is by breaking it up into a perfect square number and a non-perfect square number. So you think about what are the factors of 12, meaning what numbers multiply to 12 where one of those numbers is a perfect square number. So if I look at my list, I'm only going to be looking at these three numbers here because these are less than 12. So 4 is a factor of 12. 4 times 3 is 12. And now I can simplify the square root of 4. The square root of 4 is 2. The square root of 3 doesn't change. It stays the same. And so that is my answer in simplest radical form. For something like the square root of 72. So remember, we're looking for the biggest perfect square factor. So 9 is a perfect square factor. 9 times 8 is 72. However, it's not our biggest perfect square factor. If I take 36 and do 36 times 2, the square root of 36 is 6, and the square root of 2 stays the same. So if you use 9 and 8, you would have had to then break up 8 because 8 can break up further. So again, as your little hint here, that you always want to look for the largest perfect square number. So not just any perfect square, the biggest perfect square factor. You may recall some of these problems from algebra. If I had a setup of a proportion, how would I solve for x here? So this is our multiplication, or cross multiplication, excuse me, where I would multiply 35 times x to get 35x. And then I would do 8 times 140. So that gives me 35x equals, let's see, that would be 1,120. And then I would divide both sides by 35 to solve for x. And you get that x is 32. A ratio is when we have two numbers and we can write them sort of in two different fashions. We can write them as x is to y, or we can say x is to y, sort of as a fraction. What you need to remember is that a ratio is a comparison of two units. So anytime you are simplifying a ratio, your answer should always have two numbers in it instead of one. So something like this, 20 miles to 5 miles, if I said simplify that ratio, each of these numbers is divisible by 5. So what that essentially means is that if I was looking at a map or something, or if I was maybe talking about a race, that for every 4 miles I ran, you ran 1 mile. So notice, I didn't just write 4 here. It's not 20 divided by 5 is 4. You have to make sure that you write both numbers so that we still have a comparison. For number 30, notice we have two different units here, but when we're simplifying a ratio, that's okay because we're sort of almost doing it like if it was a blueprint and then building it in real life. So realistically, 12 over 36, if I simplify that, technically becomes 1 foot for every 3 inches. So maybe 3 inches on the blueprint translates to 1 foot in real life. And that's sort of our simplifying of ratios. We did some word problems back in algebra. So this really, right now, is just all a big review of algebra. That if I told you the ratio of boys to girls at Rockridge is 2 to 3 respectively, that word respectively just means that the order that this is presented is the order that those numbers represent. So if boys was first, boys gets 2, girls gets 3. And then it's if there are 344 boys at Rockridge, how many girls are there? So we're sort of setting up our proportion, and we can say boys to girls. And then we can say for every 2 boys, there are 3 girls. And then if there are 344 boys, how many girls are there? And then just like we did in that earlier problem, we're going to cross multiply. So we get 2x is equal to, what does that come out to be? 1032. And then when I divide both sides by 2, you get 516 girls. All right, here are some rules about reciprocals. You may remember the word reciprocal from algebra or from earlier this year when we talked about slope. Reciprocal is when you take a fraction, so if I had 2/3, the reciprocal would be 3 over 2. That's a reciprocal. So if I have these proportions, or this proportion here of A over B equals C over D, I can do the reciprocals of each of those fractions, and it still gives me the same thing. If I cross multiply, I get AD equals BC, whereas if I cross multiply here, I still get AD equals BC. So it doesn't matter if I flip the fractions around, I'll still get the same products. Similarly, I can take this proportion again, and I can switch B and C. I can switch that as the fraction, and so I can say A, if I cross multiply here, I get AD equals BC. If I cross multiply here, I still get AD equals BC, so it holds up. This last rule of reciprocals here is saying if I have a fraction AB equals CD, and if I take the denominator and add it to the numerator, that I can take this denominator and add it to its numerator, and it maintains that the fractions sort of hold up. So those are our 3 properties of reciprocals. In this chapter, we're going to be looking at what are called similar figures. And so that's kind of what this symbol represents, this little symbol here. We talked about congruent shapes. Now we're going to talk about similar figures. Similar figures are proportional, and we're going to talk more about this in the next section. Oops. Proportional. So instead of the sides being congruent, the sides end up being sort of a proportion. So for this one, we're asked to solve for x, given that MLN is similar to PRQ. So instead of setting these two sides equal to each other, what we're going to have to do is set up a proportion, and we're going to have to say that this side, ML, is similar to side PR, which is 7.5, and then we need to set that equal to something to help us solve for x. So now we're going to pick these two sides here because this has a y in it, and that's not going to help me. So now I can say that 5, 6 is similar to 4. And then just as always, we'll cross multiply. So if I cross multiply here, yes, we have some decimals. That means we're going to get some messy answers maybe. Just remember too, if we multiply 4 times an expression, that we need to sort of write it like this. And when I take 7.5 times 5.6, That's going to give us 42. Do our distributive property. And then solve for x. Subtract 8 from both sides, giving us 34. And then divide both sides by 4, and we get an answer of x equals 8.5. All right, so that's our answer for x. So we will talk more about similarity with figures in the next section. So we just have a couple more problems to get through. These are extended ratio problems. So given a ratio, how do I solve for a situation? So it says the measure of angles of a triangle are the extended ratio 1 is to 2 is to 3. Find the measure of the angles. So the angles of a triangle, hopefully you remember, they add to 180 degrees. So all this is saying is if I have a triangle and it has some angle we don't know, x, it's saying that one of the other angles is 2x and the last angle is 3x. So how do I solve for these angles? Well, I know these three angles add up to 180. So I would add that, set it equal to 180. So you end up getting 6x equals 180. Divide both sides by 6, you get x is 30. So now if it says find the measure of the angles, we want to solve for all three angles. So that means this angle here is 30, this angle would be 60, and this angle would be 90 degrees. And if you add those together, 30 plus 60 plus 90 equals 180. So it works out. In the next one, it says the ratio of AC to BC to AB is 5, 4 to 2. Find the value of x, and then find the length of each side. So similarly to the angle problem, now remember, sides don't add up to 180. So all we're going to do is we're sort of going to buddy up a number to a side. So side AC gets a 5, kind of next to it. Side BC gets a 4 next to it, and side AB gets a 2 next to it. So now to solve for x, you basically can pick any of those two sides and then kind of go through and solve for x. So I'm going to pick these two sides, but again, you can pick any two you want. And then you're going to set up a proportion. So we're going to start with the numbers, 2 is to 5, and then match the side that goes along with it. So 2 goes with 2x, 5 goes with 2x plus 6. And then just like we did earlier, we're going to cross multiply. So I get 10x equals 2 times 2x plus 6. Distribute. Subtract 4x from both sides. And then divide by 6. We get x is 2. So now to solve for the sides, what's the length of AB? We're going to substitute a 2 in for x. So 2 times 2 is 4. Substitute a 2 in for x here. 10 minus 2 is 8. Substitute a 2 in here. 2 times 2 is 4, plus 6 is 10. So those are my side lengths. All right, the last problem that we are going to look at today is our perimeter problem. It says the ratio of the lengths of the width of a rectangle is 4 to 3. So length to width. So this represents the length, this represents the width. If the perimeter is 49, find the width. So perimeter of a shape is when we add all the sides together. So I'm going to draw a rectangle here. So we know that the length is some value 4, so I'm going to call it 4x, because we don't really know how long it is. And then we know the width is 3x. This is a length, this is a width. And I know the perimeter equals 49, so that means if I add these sides together, it's going to equal 49. So I combine my like terms here, so that's 8 and 6. It gives me 14x equals 49. When I divide both sides by 14, I get 3.5. So now the question's asking us to find the width. So if the width was linked up with 3, that means I now need to take this value and do 3 times 3.5. And when I do that, I get a length of 10.5 feet. Alright, that is it for our first video. Thank you for watching.